Hi, this is Rowan. My project is to generate tweets using generative adversarial networks. In this work, we try to explore the possibility and challenges of applying GAN network to the task of generating tweets with a specific language style. We choose President Donald Trump's tweets as a case study because Donald Trump's tweets are very kind of unique and with a very specific language style. We start with a baseline model that give with the three layers of LSTM, and we put a 15 as a token length. And after about 20 epochs, it actually gives us quite good results. So if we can see that with different temperature, sometimes it can actually gives us some meaningful, like this one, the Democrats are trying to get rid of the people of the USA. And see, and this is actually very surprising because this baseline model can already capture the pattern and the style of President Trump's tweets. And then we start with a sequence scan model. This is called a SecGAN. This is a paper published in 2017, and we use the same as we use the same three layer as the generative part, basically the generator, and we change the discriminator with a final layer with a sigmoid. And but for this model, after we train for a while, we start to observe some cases like a mode collapse, which some tokens just keep showing up and just kind of stuck in this mode. So we check some literature and find out that this is kind of called a mode collapse. But for now, we're still investigating the reason why this is happening, and a suspicious one possibility is like the hyperparameters are not very well tuned. And then we actually tried another kind of open sourced implementation, and this one is called a TaxiGen, and this one claims to have fine-tuned, well-tuned hyperparameters, and we tried three of them. And for this one, the SecGAN gives us somehow a little bit better result, but still, if you can see that it's not good. It's not even as good as the baseline LSTM model. And then we tried two others, and for the Maligan, it gives us similar results as this second. For leak again, it gives us a little bit better kind of results. And if you can see that here, that many sentences, at least their phrases are looking good, and the whole sentence are, uh, you know, I would say organized in a better way compared to the SecGAN, maybe similar to the baseline LSTM. So from our result, we find that GAN network, when we use GAN network for text generation, it is still kind of requires some more research and efforts in both how to tune the hyperparameters, how to design the cost functions, and whether the training set needs to be bigger or in a different way. So these are the results that we observed. Thanks.